Hello and welcome to the final part of the ABG discussion. We were discussing practical patient problems. So coming to the next one, and pH is 7.48, PCO2 is 48, PO2 is 90 and bicarb is 38. Sodium here is 135 and chloride is 85. Okay, so the first step is anion gap. Now anion gap here would be 135 minus 85 plus 38, so that would be 12. Delta gap is 0, so there is no anion gap acidosis. Now look at the pH and PCO2. pH is going up, PCO2 is going up. They are going in the same direction, so it is a metabolic process, and pH is going up, so it is metabolic alkalosis. Now for metabolic alkalosis, let's see what is happening for bicarb and PCO2 ratio. Okay, so bicarb has gone up from 24 to 38, which is by 14 units. PCO2 has gone up by 8 units, which is pretty close to a ratio of 2 by 1, and that's what we had in our Winter's formula in metabolic alkalosis. So this is an example of pretty straightforward metabolic alkalosis. Right, so let's go back to the next one. When pH is 7.45, PCO2 is 20, PO2 is 75, bicarb is 15, sodium is 140, and chloride is 95. Right, so first step is anion gap. The anion gap would be 140 minus 95 plus 15, so that would be an anion gap of 30. That's a huge anion gap. Now look at the delta gap. Delta gap would be 30 minus 12, so that's 18. Okay, so first thing, anion gap is 30, or it is anion gap metabolic acidosis. Right, now delta gap is 18, so that means the whatever extra acid was added to the weak acid was added to the body has released 18 negatively charged bodies, which are contributing to the wide anion gap. Now these 18 negatively charged ions must have released 18 protons. Those 18 protons must have been buffered by 18 bicarbs. Now 18 bicarbs have been utilized by the body, so the bicarb should have dropped from 24 to 6. But what is your present bicarb? Present bicarb is 15, so that means body is gaining bicarb, so this becomes metabolic alkalosis as well. Okay, so since body has released 18 protons, so there should be 18 bicarbs which were utilized, and if 18 bicarbs have been utilized, this should not be 15 here, this should be somewhere around 6. So that means body is gaining bicarb, and that becomes metabolic alkalosis. So we have seen this patient has metabolic acidosis and metabolic alkalosis. Now since this patient has got a huge metabolic acidosis, wide anion gap metabolic acidosis, let us see the Winter's formula here. Okay, so bicarb, PCO2. Now bicarb has dropped by 9 units from 24 to 15. PCO2 has dropped from 40 to 20, which is 20 units. Now this ratio is not close to 1 by 1 of anion gap metabolic acidosis or metabolic acidosis. So what is happening here is, if bicarb has dropped by 9 units, the PCO2 should have dropped by 9 units only. So it should be somewhere around, you should get a reading of around 31 of PCO2. But what is happening? PCO2 is dropping much more as expected from our Winter's formula. So what is happening? Your patient is breathing faster. See, bicarb has dropped by 9 units. PCO2 should have been dropped by 9 units. But it is dropped by 20 units. That means the patient is puffing out throwing out the carbon dioxide at a faster rate, which means that you have an associated respiratory alkalosis as well. Okay, so we had metabolic acidosis, metabolic alkalosis, and we applied Winter's formula. We saw that bicarb should have been dropped by 9 units, but it has dropped, the carbon dioxide has dropped more as compared to bicarb. So that means the patient is breathing at a faster rate, and this says that the patient has got respiratory alkalosis as well. Okay, so let us see the final problem here and see how we will solve it. Right, pH is 7.36. This is a very interesting one. PCO2 is 39, PO2 is 90, and bicarb is 23. Okay, if somebody tells you this is an ABG picture, what would you say? Looks like normal to me. pH is 7.36, PCO2 is 39, okay, PO2 is 90, and bicarb is 23. So looks like a normal ABG. Now look at sodium. Sodium is 140. Chloride is 80. Right. So what is the first step? Anion gap. Anion gap would be 140 minus 80 plus 23. So that becomes a huge anion gap of 37. See, the picture which looked pretty normal to us without having a look on the anions actually comes out to be an anion gap metabolic acidosis. Right, so what is the delta gap? Delta gap would be 37 minus 12, because 12 is the expected anion gap in this patient, so that is 25. Okay, delta gap is 25. What does it mean? It means that whenever the weak acid was added to this patient, this weak acid has released 25 negatively charged ions, which have contributed to increased anion gap. So these 25 negatively charged ions have released 25 protons. These 25 protons would have consumed 25 bicarbs. So your present bicarb should drop by 25 units, but you have a bicarb of 23. Okay, so that means body is gaining bicarb, so that becomes metabolic alkalosis as well. Okay, so completely normal looking ABG picture, and when we calculated the anion gap and we saw it's a huge anion gap, huge load of protons on the body, and we saw it's like a tug of war between metabolic acidosis and metabolic alkalosis, because 25 protons which were released, they would have consumed 25 bicarbs, and this bicarb has not dropped, so there is metabolic alkalosis as well. Okay, well, that concludes the discussion on ABG. Thank you very much for joining us on ABG discussion.